In this video, we're going to be looking at radicals. Our objectives are to understand how to simplify radicals and to understand how to find exact radical when solving vertex form. Our vocabulary: radical, a square root. Radical expression, solution with square root. So it's a problem that has a square root in the answer, and we don't take it out, we don't estimate it with our calculator and round the answer. We leave it in the problem. So typically what we've done with square roots is we have square rooted the number, and if it came out perfect, great. If it didn't come out perfect, we've been rounding the answer. Such as square root of 20. It does not come out perfect, so up until now we would have just rounded the answer off. In this case, we're going to find a simplified version of it. To do that, we need to be able to do our tree factoring from elementary. So we're looking for prime numbers. So 2 and 10 make 20. So I'm going to keep the 2. 10 comes from 2 and 5. Okay, so we have the square root of 2 times 2 times 5. What we then do is we look for doubles. 2 and 2 make 4. So I'm going to square root 4. I'm going to square root 5. Well, the square root of 4 comes out exact. It's 2. Square root of 5 is a decimal, so we're going to leave it the square root of 5. So the square root of 20 in exact terms is known as 2 times the square root of 5. Let's look at a little bit more difficult one in 54. 2 times 27. 2 is prime. 27 comes from 3 and 9. 9 comes from 3 and 3. So our square root here is square root of 2 times 3 times 3 times 3. Again, we're going to look for doubles. We have a 3 and a 3. That's going to make the square root of 9. Then we have the square root of 2 and the square root of 3. No doubles, we don't multiply them. Square root of 9 is otherwise known as 3. The square root of 2 and the square root of 3 can be lumped back together. 2 times 3 is 6. So we have 3 times the square root of 6. We're going to use this ability to simplify to then find exact answers for vertex form when we solve. One of the reasons that we like to simplify a radical is so that we can then add like radicals. So think of it like combining like terms. If you have the exact same radical, you can add or you can subtract. Notice both have a square root of 2, meaning we can add the 3 and the 8. So this becomes 11 square root 2. Both of these have the square root of 6, so we can subtract 4 minus 2 gives us 2 radical 6. Notice these two radicals are not the same, so what we have to do is write them in their simplified versions, and then if they have the same radical, we can add them. If they don't have the same radical, we just write them the way they are. So square root of 12 is really the square root of 2 times 2 times 3. 2 and 2 give me square root of 4 square root of 3. So that looks like we're going to have 2 square root of 3. Now we've got to do 75. 5 and 15. 5 and 3. So we've got the square root of 5 times 5 times 3, which would be the square root of 25 square root 3, as those are doubled, which is going to give us plus 5 square root 3, because we're going to square root that 25. So now both have square root of 3, meaning we can add them. This is 7 square root of 3. Alright, now let's see what we can do with this in vertex form. So here we have two equations that we're going to solve for the roots, or one we're going to solve for the roots, one we're just going to solve. So we've got a 0 and we're solving this one for the roots. We're going to try and find an exact answer rather than square rooting a number and rounding the decimal. So add 5. Okay, now we're going to square root. Now 5 doesn't square root perfectly, and it doesn't factor down, so square root of 5 is actually our answer, but we need a positive and negative, so we're going to go square root of 5 equals x plus 1, and negative square root of 5 equals x plus 1. We're now going to add or subtract 1 on both sides. Well, these aren't like terms. One has a square root, one doesn't. So this is square root of 5 minus 1 equals x. And this one would be negative square root of 5 minus 1 equals x. Now we've got a little bit more difficult problem. I'm going to add 28. And divide by 2. Now I'm going to square root. That's going to give me 2 answers. Well, the square root of 12 actually can be simplified, so I'm going to go through this work really quick. Square root of 12 becomes 2 times 6, 2, 3. 2 2's make 4. So I'm going to square root 4, square root 3. Square root of 4 is 2 square root 3 equals x minus 2. And negative 2 square root 3 equals x minus 2. Notice I can put my simplified version in and just put a negative sign in front of the negative version. Then I'm going to add 2 to both sides. Now, this 2 doesn't have a square root next to it, so I can't add them because they don't have the same square root. So I've got 2 square root 3 plus 2 equals x. And in this one, I'm going to add 2. And again, I can't combine them. They're not like terms. Negative 2 square root 3 plus 2 equals x. Alright, this has been a introduction into simplifying and working with radicals. If there's any part of this that you didn't understand, make sure you pause, rewind, and rewatch, and bring your questions to class. Thank you.